So friend, today we are going to discuss this limit of a sequence, or it is convergence of a sequence. Now see, last time we have seen the definition of sequence. What is the definition of sequence? A sequence, it is a function whose domain it is a natural number and codomain it is a set of real number. This is called a sequence. For example, we can take sequence as a n equal to 1 upon n. This is the example of sequence. Now see, what is the definition of convergence of sequence? Now, convergence of sequence, it is related with sequence, it approaches towards certain point. See, convergence sequence. Convergence sequence means sequence, it approaches towards certain point, that is the convergence of the sequence. Now see, what is the definition of the convergence of the sequence or limit of a sequence? Suppose if you take Sn as a sequence, which is a suppose sequence of real number, then this sequence Sn approaches to the limit L, means that for every epsilon greater than 0, there exists a positive integer n such that modulus of Sn minus L, this is less than epsilon, for all n greater than or equal to n, where what is this n? N, this is depends upon epsilon. See, what is the definition of convergence of the sequence? A sequence Sn, it is said to be converges to the limit L, means that we have to choose epsilon greater than 0 and we have to find out some integer n such that this condition hold, that Sn minus L, this is less than epsilon for all n greater than or equal to capital N, where what is this n? N, it is depends upon epsilon. Now see, I will show you how this capital N, it depends upon epsilon. Now see, if we consider suppose sequence Sn equal to suppose 1 upon n. Now first of all, write down all the term of the sequence. So how to write all the term of the sequence? We have to take this element n from the natural number. Put n equal to 1, 2, 3 and so on. So what is the term of this sequence? This is equal to, put n equal to 1 means this is 1. Put n equal to 2, so this is 1 half, this is 1 upon 3, 1 upon 4, 1 upon 1000 and so on. So these are the term of the sequences. Now see, in the definition of convergence of sequence, what is the process? We have to choose epsilon greater than 0 and we have to find out this integer n. Having this condition, the modulus of Sn minus L less than epsilon. Now suppose if we consider this sequence Sn equal to 1 upon n, then what is our first observation? If you put suppose, or if you write the term of the sequences, then what is our first observation? This sequence, it approaches towards the limit 0. What are the term of the sequence? It contains 1, 1 half, 1 upon 3, 1 upon 4, 1 upon 10,000, 1 upon 1 lakh. So it approaches toward the limit 0. So obviously 0, it is the limit of this sequence. Now what is this condition? We have to choose epsilon greater than 0. We have to take this condition. Okay, we have to choose epsilon greater than 0 and we have to find out this capital N. Satisfying this condition, which is the condition, modulus of Sn minus L, this is less than epsilon for all n greater than or equal to capital N. Now what is Sn? Sn means our given sequence, that is 1 upon n. What is the limit of this sequence? Limit of this sequence will be 0. So let us put L equal to 0. So this is less than epsilon. So what is this equation or what is this condition? 1 upon n, this is less than epsilon for all n greater than or equal to capital N. Now suppose, if we choose suppose epsilon equal to suppose 0.1, see, we will show that this capital N, how it is depends upon epsilon. Now suppose if we take epsilon equal to suppose 0.1, now what is this condition? Okay, 1 upon n, this is less than epsilon. Now let us put the values of n from the natural number suppose. Now see, if you put suppose n equal to 1, then what is this left hand side? 1 upon 1 means it is 1. We have taken the value of epsilon equal to 0.1. So this 1 upon 1 means 1. 1, this does not less than 0.1. So if you put n equal to 1, so this condition does not hold. Now suppose if you put n equal to 2 suppose, then what is this left hand side? We get modulus of 1 half. Modulus of 1 half means it is 0.5. 0.5, this does not less than 0.1. So if we take suppose n equal to 2, then again this condition, this is not satisfied. Now if you put suppose n equal to 3, again obvious, we get this left hand side as 1 upon 3. 1 upon 3, this does not less than this epsilon. We have taken epsilon equal to 0.1. So this does not less than 0.1. So for n equal to 3, again this condition, this is not satisfied. Now if you put in the same way, suppose if we put suppose n equal to 10 suppose, then what is the value of left hand side? 1 upon 10, that is 0.1. Still this does not less than this 0.1, which is epsilon equal to 0.1. So if you take suppose n equal to 10, then again this condition of convergence, it does not satisfy. Now suppose if we take n equal to 11 suppose, then what is the left hand side? It is 1 upon 11. If we take suppose n equal to 10, then the left hand side will be 1 upon 12. If we take suppose n equal to 13, then what is the left hand side? It is 1 upon 13. And all these quantity, this is less than this epsilon, that is the 0.1. So if we take suppose n equal to 11, 12, 13 and onwards, if we take n equal to 11 and onwards, then the condition of convergence, it is satisfied. So if we take suppose epsilon equal to 0.1, then what is our this capital N? Capital N will be 11 or greater than 11. So see what is the definition of this convergence of the sequence. We have to choose epsilon equal to something, and we have to find out this integer capital N such that modulus of Sn minus L, it is less than epsilon. So this capital N, it depends upon this epsilon. Now suppose if we take suppose epsilon equal to suppose 0.01 suppose, then what is this condition? If we take suppose n equal to 1, then what is the left hand side? It is 1. This 1, this does not less than this epsilon, which is 0.01. If we take suppose n equal to 2, then what is the left hand side? Which is 1 half. 1 half means it is 0.5. Again this is does not less than this 0.01. So for n equal to 1, 2 up to n equal to 100, this condition modulus of Sn minus L less than 1, this does not satisfy. If you put suppose n equal to 100, so what is the left hand side? 1 upon 100. 1 upon 100 means it is 0.01. Again still it is does not less than 0.01. So if you take n equal to 1 up to 100, then this condition, this is not satisfied. Now if we take suppose n equal to 101, then what is the value of this left hand side? 1 upon 101, obviously it is less than 0.01. Suppose if we take n equal to 102 and so on, this condition it is satisfied. So what is the value of this capital N? Capital N will be 101. So see, this capital N, it is depends upon epsilon. If we choose suppose epsilon equal to 0.1, then what is our integer n? The value of n is greater than or equal to 11. If we take the integer n is greater than or equal to 11, then the condition of convergence, that modulus of Sn minus L it less than epsilon, it satisfied. If we take suppose epsilon equal to 0.01, then what is the value of our integer? N will be greater than or equal to 101. So obviously this n, it depends upon epsilon. So see what is the definition of convergence of a sequence. A sequence Sn converges to the limit L means that for epsilon greater than 0, there exists integer n such that modulus of Sn minus L, this is less than epsilon for all n greater than or equal to n, where what is this n? N depends upon this epsilon. So this is what the definition of convergence of a sequence. Now say if we simplify this condition, then what is this condition? Okay, this modulus, this is less than epsilon. So obviously this sequence Sn, it lies between this L minus epsilon to L plus epsilon. What is this quantity? This sequence Sn belongs to this open interval L minus epsilon to L plus epsilon. So what is this quantity? This is nothing but the epsilon neighborhood of this L. Now see, this is our L and this is the epsilon neighborhood of L. It is L minus epsilon to L plus epsilon. Now see, if you consider the sequence Sn equal to 1 upon n, then we are seeing that this sequence Sn approaches towards the limit 0. Now say what are the terms of this sequences? This is 1, this is 1 half, 1 upon 3, 1 upon 4, 1 upon 5 and so on. It approaches towards 0. Now suppose if you plot this point on the real line, this is 0 and this is suppose 1. Now 1, this is the point. 1 half, this is the next point, which is this middle point, which is 1 half. This is suppose 1 upon 3. This is 1 upon 4. This is 1 upon 5. This is 1 upon 6. 1 upon 7. This is suppose 1 upon 10 and so on. Now see, what is this meaning of Sn belongs to this neighborhood L minus epsilon to L plus epsilon. Now suppose if we consider suppose sequence Sn equal to 1 upon n, and just now we have seen that if we take suppose epsilon equal to 0.1, then what is our this existence number? Our natural number will be, this is greater than or equal to 11 suppose. If you consider suppose epsilon equal to 0.01, then what is our natural number? It will be greater than or equal to 101. So if epsilon it is small, then the value of capital N, it is some large number. If we choose epsilon, it is again so small, then this capital N, our integer, that is a very, very big number. Now see, this sequence Sn, it converges to 0. So this is our 0. Now suppose if we take suppose epsilon equal to 0.1, then there exists this natural number which is greater than or equal to 11. Greater than or equal to 11 means this is the 11th term of the sequence, that is 1 upon 11. See, Let us choose suppose epsilon equal to 0.1. Then what is our integer? N should be greater than, either it is greater than 11 or it is equal to 11. So if we take this 11 term of the sequence, then this is 1 upon 11. So after this 11th term, all the term of the sequence that is in the neighborhood of this limit. See what is the meaning of this? Sn belongs to L minus epsilon to L plus epsilon. After, see what is the meaning of Sn belongs to L minus epsilon to L plus epsilon. If we choose epsilon equal to 0.1, then what is our natural number? There exists this natural number which is greater than or equal to 11. So this is the 11 term of the sequence. So after this 11 term, all the term of the sequence, it lies in this neighborhood. So see, what is the geometrical meaning of this convergence of the sequence? A sequence Sn converges to the limit L means that we have to choose epsilon greater than 0 and we have to find out this integer n such that the modulus of Sn minus L, this is less than epsilon, and this condition is true for all n greater than or equal to capital N. So what is the meaning of this condition? After this natural n, after this condition, after this stage, all the term of the sequences, it lies in the neighborhood of that particular limit. If you consider suppose sequence Sn equal to 1 upon n, then 0 it is the limit. This is the position of 0, this is 1. 1 up means it is the midpoint. This is 1 upon 3, this is 1 upon 4. And this is the 11th term of the sequence, that is 1 upon 11. So this is the finite number of stage, 1 to 11. After 11 term, all the term of the sequences that is lies in this neighborhood of the limit. Our limit it is 0, so this is our neighborhood of this limit. So remember this concept. A modulus of Sn minus L, this is less than epsilon, means all the term of the sequences, it lies in the neighborhood of that limit. So thank you for watching.